Okay, so in this lesson, we're going to learn about nonlinear functions. Up to this point, you've been learning about linear functions. And linear functions usually have a rate of change that is constant. Basically, when you plot the points on a graph, it is a straight line. So when you see a straight line, the rate of change is constant. However, with nonlinear functions, the rate of change is not constant or is not the same, and therefore you will see curves in the graph. So before we look at graphs, let's take a look at points and identify how we can determine when it is a nonlinear function. So let's start with the following chart. So if we take a look at the numbers going down the x column, you will see that the change from 2 to 4 is 2 plus 2. The change from 4 to 6 is plus 2. And the change from 6 to 8 is also plus 2. Now, when we go from 2 to 4 on the x side, y goes from 50 to 35. So it drops by negative 15. Then we go from 35 to 20, and it also drops by negative 15. And then from 20 to 5, it drops another negative 15. So as x increases by 2, y decreases by 15 each time. This is what we call a constant rate of change. So this function is considered linear. Linear function. Because rate of change is constant. Now, if we take a look at the following chart, here's what we see. As x changes from 1 to 4, it increases by 3. 4 to 7, it increases by 3. 7 to 10, it increases by 3. Okay? However, going from 1 to 16, it increases by 15. 16 to 49, it increases by 33. And then from 49 to 100, it increases by 51. So as x increases by 3, y increases by a greater amount each time. The rate of change is not constant, so the function is non-linear. Non-linear function. Because rate of change is not constant. Okay, so let's take a look at an example. So in this problem, it says that we have a square that has a side length of x inches. The area of the square is a function of the side length. The question here is, does this situation represent a linear or non-linear function? So we explain. We need to explain. Okay, so we need to read this problem again. A square has a side length of x inches. Okay, so let's write this down. Side length okay, and this is in inches. And then the area measured in square inches or inches squared, okay, is a function of the side length. Okay, so the side length, or the length of the side, determines the area of the square. Okay, so we need to put in some values and see what is going on. Okay, so if a square has a length of 1 for one of its side, then the area will be 1, because it's 1 times 1 equals 1. When the side length is 2, the area is 4. When the side length is 3, the area becomes 9. And when it's 4, it becomes 16. And then when it's 5, it becomes 25. So when we take a look at the change in x, okay, or the side length, we see that going from 1 to 2 is a change of 1. Going from 2 to 3 is also a change of 1. Going from 3 to 4 is also a change of 1. And going from 4 to 5 is a change of 1. Okay? Now, for the area, when we go from 1 to 2 in the side length, the area goes from 1 to 4. And that is a change of 3. Going from 4 to 9, as the side length goes from 2 to 3, we have a change of 5. Going from 9 to 16, as the side length goes from 3 to 4, we have a change of 7. And then going from 16 to 25, as the side length goes from 4 to 5, the area increases by 11. So, to answer the question, does this situation represent a linear or non-linear function? The answer is nonlinear. Okay, and we need to explain. Well, because the rate of change in the area is not constant. Because rate of change in area is not constant. Okay, so that is pretty much it. We learned about linear functions earlier. Today, in this lesson, we learned about nonlinear functions. Nonlinear functions are situations where the rate of change is not constant, whereas linear functions, the rate of change is constant. If any of this was confusing to you, please go back to the beginning of the video and review it again for further clarification. Thank you.